Alright, in chapter 3, we are going to talk about the first couple of lessons. The whole concept are systems of equations. So we're going to learn how to write and to solve all different types of systems of equations. So when we go to write a system, it just depends on how the story problem is laid out for you, because there's a couple different ways you can write them. You can write them in slope-intercept form. But you're only going to want to do slope-intercept form if they give you a one-time amount, and then they give you some kind of per item, like $150 per ticket or $30 per hour, something like that. You can write them in standard form. And standard form is usually when they have two different per items. And they give you a total amount. So usually when you see a total amount, you want to do standard form. This accounts for 99% of your time. Now there's a third option that shows up once in a while, and it's a comparison problem. So for example, Mary made twice as much as Jack, or something like that. So let's take a look at this example. We're just going to be writing them, and then we can start solving them a little bit later, but we just want to write out the problems. So it says tickets to a local movie were sold for $3 for adults. So that's kind of like your imaginary per, $3 per adult, and $150 for students, or per student. So you notice that we've got some pers going on here. If 73 tickets were sold for a total, right, so that tells me I'm going to do standard form. And not only am I going to do standard form, but there's two different concepts here. We have one equation dealing with all money, and one equation dealing with the number of tickets. So let's go ahead and take a look at the money problems. We've got $3 per adult, so I would call that 3A. You can give it any variable. I usually pick the variable that kind of corresponds to the word. And, so together we're going to plus it, $150 per student. So I'm going to put 150S. So it's 3 times the adults, and then adding on to 150 times every student, and that's a total of what? Well, remember that this is money, and this is Monday. So your total amount of money is $199.50. So we've used that, and we've used this, and we've used this. Okay. So now let's look at the next type of a concept, number of tickets. Okay, do you know how many adult tickets were sold? No. So we're just going to leave that as a variable because we have no idea. But we know that if we add up the amount of adult tickets and the amount of student tickets, it should give us our total amount of tickets. And so take a few minutes and see if they give you the total amount of tickets. Yeah, total amount of tickets were 73. So now this is how you write the system. So this would just be the system. Now if I ask you to solve for either the adult or the students, then you could go ahead and start solving. But for right now, I just want you to write the equations out. Alright, Ace Rent-A-Car charges a flat fee of $15 and then 24 cents a mile for their cars. Acme Rent-A-Car charges a flat fee of $30 and then 16 cents a mile for their cars. So let's talk about Ace. Okay, it's a flat fee, and then it's so much money a mile, which is your imaginary per mile. So because there's a one-time fee and then a per, that's going to be slope-intercept. So we're going to go 15 plus 0.24 per mile, and that is Acme. Oops, sorry, Ace. Now Acme rents for a flat fee of $30 and then 16 cents per mile, so it's another slope-intercept. Per mile. And how many miles does Ace Rent-A-Car cost the same as Acme Rent-A-Car? So let's kind of put these in terms of variables. So this is the same thing as saying y is equal to 0.24m plus 15, if you want to look at it more in the slope-intercept form. The second one is y equals 0.16m plus 30. Okay, so one of the ways that we can start solving is by graphing them. So we're going to go ahead and graph, and of course you would have graph paper, right? So then what you would do is you would start this one up 15, and then you would find the slope. Well, 0.24, we would change that to its equivalent fraction, which we've talked about that before. The buttons on your calculator do that. The reason we want that as a fraction is so we know what to rise and run. So that's an equivalent of 6 over 25. So then we would go up 6, and we're going by 5s here. You would go up 6, and then you would go over 25. So if I go up 6, I'm right above the 20 and over 25. And again, it'd be much better if you had graph paper. So here's that line. All right, let's look at the second one. We're going to start at 30. So here's 30. And this slope is 0.16. So let's change that to a fraction. So now from here, I'm going to go up 4, which is just under here, and then over 25. And you'll notice that they would eventually end up meeting off to the side here. So we're going to have to figure out where they meet. Wherever they meet, that would be my answer to the problem. And then once you get done finding the answer to the problem, you're going to have a coordinate. But you got to remember what these we're dealing with. This x coordinate right here was your miles, because remember m stood for miles, and the y coordinate was going to be your total cost. So at any point, I can tell you, well, if you travel 28 miles, then this is how much it's going to cost you. If you travel such and such miles, this is how much it's going to cost you. So one way to solve a system of equations, if you remember from Algebra 1, is to graph them and figure out where they hit each other.